It's 2020, March, during the COVID-19 lockdown. So I thought I'd show you my electric boats that I made. The one I raced in 2019, the big one, and then this smaller one I've made for the 2020 season, which we don't know if it will ever occur. Anyway, a bit of background. Now this is in the UK, and these boats are made to race in the OMRA championship under their rules. OMRA stands for Offshore Model Racing, and it refers obviously just to boats. Why offshore? Well, offshore means in the sea, and offshore from either the beach, the side of the marina like the pier, and occasionally you will follow the boat in a so-called chase boat. Why in the sea? Well, they're much too big really for lakes. You need quite a big lake to race these if you had like 8 of them going round. Most lakes are much too small, and you can find the odd large lake, but they were made for offshore in the sea. And historically, that's what they've been doing since 1971. Now, these two are electric boats, and this big one here was the first year in 2019 that they introduced the electric boats as an experimental class. Prior to that, all the boats were either petrol powered or nitro fuel powered. And there was a number of different classes. Generally, they're still quite large because in the sea, obviously, with all the waves and the conditions, you can't really race small boats. You can put small boats in, but they tend to be a bit unstable and get knocked about a lot, especially if it's rough. So the boats tend to be quite large. This is not quite the largest one. It's 145 centimeters hull length. There are some a bit bigger, by say about another 10 centimeters, and they're all in these classes from Z. And then the electric class was put in a class called the X class, or experimental class, where you could have other forms of propulsion besides the petrol or nitro. But so far we've only seen electric. I mean, I don't know what other ones there could be. The races, all these races actually are 20 minutes long. Now, that's quite a big ask for electric powered vehicles, considering that you've got to carry the batteries and maintain a good speed, and hopefully go as quick or quicker than the existing big boats. And some of these boats have been around for years, maybe 20, 30 years. Some of the people have been doing it, and the boats are pretty sophisticated and powerful, with big powerful petrol engines, etc. So to compete on the same terms, you've got to do 20 minutes. I built this boat from scratch. You buy the hull from this hull come from Mark Copley. There aren't many people who make hulls. You could make your own, but I think that'd be pretty difficult. This one's been developed over some years. So you buy the empty hull, and then I fitted it all out, and with the design and the layout of everything inside, and the position, and I did some testing. I could test it on the lake. Obviously, you can't go flat out when other boats are around there, but I tested it on the lake before it hit the sea, and there were a number of teething troubles, but I got there in the end. Now, as I said, 20 minutes required pretty big batteries, and I worked it all out by theory and by experimentation, and then the size of the propeller, everything, and the way you drive it under the conditions to do the 20-minute race. And I must say, eventually it was successful. And the last race of the year, the number of races, as you can see, they go this is around the south coast of England, basically, from the Isle of Wight, Torquay, right down Bristol, Bristol's an inland dock, but very large historic dock waterway, and right down to Penzance. And the Penzance one was the last one of the year, and it's in fact where everything came together. And I did particularly well there. And they not only have 20-minute races. In fact, there's two 20-minute races, one in the morning, one in the afternoon. Luckily, there's a gap between them, including lunch, which enabled to recharge these lipos because they're very expensive, and there's no way I was going to have two sets of these. So I have to recharge these, and that takes quite a time because my charger will charge at 25 amps maximum charge rate, and it still takes a couple of hours to charge these up from flat. I'll talk about those a bit later on. So just finishing up about the championship. So they did two 20-minute races, and I was up against a couple of other electric boats. Not many. I mean, that's an experimental class. People are still trying to develop and make their boats. And some of the people have decided that they would stop about 10 minutes, bring their boat to the side and swap out the batteries, use smaller ones and put a new set in and then carry on. But I decided not to do that. I thought it was a bit slightly dangerous because the weather conditions are very bad, trying to swap out high power lipos if it's raining or rough water, whatever. Anyway, I did it these for the whole 20 minutes, and I managed to win both races and got the awards. This is the one from Penzance. It says X class race first. Now the other, and I've won some others as well. There's one at Bristol first, and Isle of Wight first place. And the other thing is they do is every boat goes out but does 5 laps, one after the other, not all together, and see how fast you can go, and they can record the fastest lap. And my boat, up against all of them, every single boat, that from the very biggest down to whatever's entered, they all have a go, and I was the fastest boat by quite a margin actually over the others. And at the AGM also I got an award for the best engineering of the boat, because it is a development class and no one's made a boat, let alone made one that can do 20 minutes, an electric boat. So I was pretty proud of that. Yeah, I had a few setbacks, but it's pretty much working pretty good now, and I will keep it going for 2020. Now at the AGM they decided that to make a boat like this is quite difficult for most people, and quite expensive. One reason why it's expensive is the batteries, and it's the development of it is because everything has to be built from scratch. You can't like go and buy a kit and screw it together. It's quite an ask for a lot of people who've done petrol nitro for all their life to make an electric boat. But there are some people interested in doing the electric racing, but maybe not with such a big boat to do 20 minutes. So they decided to introduce some shorter races for electric boats between 5 and 10 minutes, depending on conditions, etc. So that's for 2020. So I now had the dilemma whether to race a big one in the short races, or I was a bit worried that a lot of people would make slightly smaller boats, and this would be like rather large up against the others going round. So, and I also wanted to keep this one if they still run the 20-minute races. So I decided to make a slightly smaller one. And this is a 125. It's called Phantom 125. It's 125 centimeters long. It's a smaller version of that one. And I'll show you the inside at the moment, and then I can run a smaller lipos and etc. And then I can have this one for the short races, and also be able to do the long races for that one. So quite successful in 2019, the first year of the electric class. A lot of people thought you couldn't do 20 minutes with an electric boat. Well, I actually did the races and completed the 20 minutes. Now, I wouldn't say it was straightforward, because you can go flat out, depending on the conditions. If it's rough, you can't, but if you can, you could drain the batteries. So I actually have on my radio, I'll show you a bit later, telemetry coming from the boat. I'll just show you. On here, you've got the current being drawn by the motor, the temperature. I can measure the temperature of the motor as well, just in case something's going wrong, it overheats. RPM of the motor, so, and which I use when testing mainly, and the voltage of the LiPo, and these have got alarms on them so that if the LiPo goes flat, I know. And the capacity. Now with the capacity, I can tell that, say in a 20-minute race, at 10 minutes, this is 32,000 milliamps. I'll talk about that in a minute, the capacity. So at 10 minutes, I want to know that I'm at not more than half of the capacity, 16,000. So you have to have someone with you as a spotter, looking out for recovery boats and all sorts of boats that are stopped, so he can tell me what the current is at 10 minutes. And as long as it's less than 16,000, I know I'm spot on. If it's much less, I can speed up. And if it's too much, I'll have to slow down a bit. And that way, I can get to the end of the race without flattening the LiPo. So that's really good that you can have telemetry. I know in some classes of car racing and that you're not allowed telemetry during the race, but in this, it's fine. And it's really important. The current draw, also I try and keep it below, would you believe, 150 amps. It peaks as you accelerate and etc. And I try and keep that down as well. In the sprint races, I'm not too worried about any of that stuff, and the current can go over 200 amps when I nail it in a straight line on the long parts. So a lot of current draw going on. Anyway, that's the radio, a Futaba one with all the telemetry set up. I'll go over each boat if you're interested, just to show you the electrics. I'll just go over how I developed this big electric boat. Do a quick look at the back. It's pretty straightforward. We've got the rudder here, obviously for steering. There's a turning vane here which it can stabilize the boat. Some people have them on both sides. And here's the it's called a stinger, because I'm not quite sure why it's called a stinger, but it's the thing that holds the prop shaft and the propeller on the end. I use, in development, I tested loads and loads of different propellers to get everything right for the motor and the voltage and the speed, and looks quite a small propeller, but it makes the boat go at the correct fast speed. So that's at the back, pretty straightforward. There are some water pickups here. There's scoops on there too, and I've got a big water pickup that just pops down below the hull and gets a good pressure in there, and that's to cool the motor. The motor gets very hot if without water cooling. No matter how efficient they say these are, it gets hot. The other two are for the speed control, which doesn't get that hot, but it's got cooling on it, so I put the cooling through, and the water goes through and it exits through these three little outlets here for the three tubes for the water, so it gets forced through. On the motor there's a sleeve which is rubber sealed, and the water obviously comes in, spins around it, taking the heat away and then pumped out. Same in the speedo, the water comes through and is forced back out by the pressure. Now on this boat as well, I did have a GoPro which I can stick on the front. I've used it a couple of times and that's tethered in case it falls off. Now for safety, you've got to be able to turn the boat off at any one time if it stops or needs to be turned off when it's not being used or waiting at the side to start. So here I've got there's an on-off switch here, which is like a pre-start, which helps charges up the capacitors on the speedo basically, and then this is the main power, which the battery comes through this. When you pull it out, it will disconnect the power whether this is on or off. And then you've got the radio. I've squeezed it all into this little box, waterproof box, and then I've sealed up the exits where the wires come out. Everything's jammed in there. Now it uses a Futaba Surface 2.4 gigahertz radio with a little aerial, and I've never had any problems with that whatsoever. It's the same one that they use in the model cars. Also all the telemetry is jammed in here. I have an on-off switch here with the voltage display showing the voltage of the battery. Now I run it off a battery inside rather than have a like a voltage reducer from the main battery, just in case there's any disconnection. I'd rather have that, and I keep that charged up, so that's completely independent to keep the radio on even if these fail in for some reason. There's not much else in here electrically. While there's a powerful, looks too small but it's not, it's easily very powerful expert servo for the rudder. As I said, all the radio equipment's in there. I also have a display here which shows when I connect it up, plus and minus the voltage. Now I don't know if you can see that. So it's 44.6 volts. It's wow. Reason for that, and it'll show me that it's only about half charged. It's got some bars on it showing you the percentage of charge. That is a high voltage because I'm just going to explain. It runs at 50 volts. You've got two of these massive batteries in series. Each is a 6S, so you're running at 12S. These are 32,000 milliamps each. And you'll see that they're only rated at 10C, which a lot of people will think, well, they must be useless because in their model cars they've got 120C, 130C batteries. But a lot of people don't understand about the C rating. It was introduced years and years ago when they first manufactured LiPos, and they were small capacity, like 1,000 milliamps, and it was to help you realize how many amps you could draw out of it. So a 1,000 milliamp battery, which is a 1 amp battery, if it was 1C, could deliver 1 amp for an hour. And then as they got more powerful, it became 10C and 25C, 30C, on and on. But they were fairly small capacitors. So say 1,000 milliamp hour battery, which is 1 ampere hour, if it was a 30C battery, it could deliver 30 amps, or 100C, 100 amps, which is still fairly within capabilities. But if this is a 32,000, and if that was 100C, that could in theory it would mean it could deliver 3,200 amps, which it can't. But a 32C at 10C, 320 amps capability. So don't take too much notice of 10C when you're dealing with these massive batteries. So 32,000 at 50 volts should be enough, and was enough to do 20 minutes with some careful driving. and also very fast for the spin race. How fast? Well, considering if you've ever watched these boats, they raise out of the water just like the real ones that you might have seen in the powerboat racing. They raise up, and you've got the propeller, which is called a surface drive propeller, which is spinning basically on the surface of the water, raises the whole boat up, and it virtually is going along just with the back in the water where the propeller is. But if it's rough, it tends to jump out of the water, jumps up and down, up and down. So the speed I got out of this was just over 50 miles an hour, which is I think about 45 knots or 80 odd kilometers an hour, which is quite impressively fast for such a big boat, and it was faster than any other of the boats there of any size, bigger or smaller. So, and that didn't happen by practice. I did a lot of development work to sort out the motor, the propeller versus the current draw. Anyway, moving on from the batteries, a motor, it's here with water-cooled jacket. Luckily, in the last few years, these motors have become a lot cheaper because they're used now in a lot of things like electric skateboards and small electric powered vehicles like that. And also, I believe they're starting to put them into bigger, like fifth scale radio control cars and that. So they become quite cheap relative for their size, and quite a different range of RPMs on them when you consider that the RPM is dependent on the voltage. I didn't need a very high RPM or kV, 1000 revs, K per volt. So I tuned that. I didn't want the revs of the propeller to be too high for the racing or too slow, and that I tuned that all up. Now the prop shaft comes in here, and I've got a little oiler there that's got a bearing at the front to help support the prop shaft and prevent any vibration, and then it drives into there on a square drive, it's called. The motor, by the way, is just like a normal brushless motor, 3 wires. The magnet is a 4-pole. In a normal electric car, fast 10 scale, for instance, would be a 2-pole, which means just the north and the south. This has got 4 poles, so it's 2 north, 2 south. But it's only 3 windings, just like a normal one, and it's only about 3 turns. It's very low, and as I say, it can draw over 200 amps when it's going hard, flat out, and so you can. That's why it needs some water cooling. But generally, I keep it about 100 amps in a race. The speed control, tried a few, burnt out a few, and I've found one now that has been reliable. It's rated at 400 amps, so not on the limit, and it says it can take up to 16s, so luckily it's in the capabilities. It still needs water cooling, but it doesn't get very hot with the water cooling. There's quite a lot of wiring in here because of the telemetry. If you weren't using any telemetry, you could do away with a lot of this wiring, but I use all the telemetry. And in fact, to show you a bit more here, this one here is the Futaba one that measures the amps. Oops. It has to be in series with the current flowing through, and it also is very good. It works out the capacity in milliamps for you as well. You start at 0 and then it counts it up. That's just a little cover for it to stop it getting spent up. Inside here, more wiring, heavy duty wiring, and I've got a fuse here, 150 amp fuse, which doesn't blow at 200 amps. Now nice heavy duty wire, I think it's 8 gauge, good heavy duty connectors. The wiring at the end of the race, it does get a little bit warm, probably loses a little bit of power, but not only warm, it's nothing gets hot, so it's not losing a lot of voltage. I mean, the wiring's got to go up through the on-off switch and back, and then through the motor, speedo, everything. Now these batteries are removable 2 ways. I've got a tray here that they're on a polycarbonate tray, which is held in by 6 screws onto a chassis rails that I installed, so I can undo them. They come out nice little thumb screws. I'll show you one, and I can lift the whole battery tray out, the 6 of them, or they're held in on Velcro. Now you might think Velcro is not strong enough to hold batteries in, but believe me, you cannot pull this off. And it gives it a little bit of flexibility, because these boats take one hell of a pounding. They've never moved yet. If they did, I could always tie wrap them. And the reason why I use Velcro as well is so that I can move them for weight distribution and tune in the boat to get the right attitude out the water. And also you get a lot of torque reaction from the motor, which means when you accelerate hard, it twists the boat clockwise, because the motor goes anti-clockwise. And if you mounted the lipos centrally, the boat twists over and goes along at an unusual angle. So unfortunately, you have to start with it to leaning to the left. Now as you accelerate, it pulls it up straight. Though it's a bit of a compromise depending on how fast you're going, so it tends to move like this a bit as you accelerate at different speeds. But it's that one advantage over the petrol boats is that they have a big tank of petrol, and as race goes on, the petrol obviously gets used up and the weight goes down, and it upsets the CFG balance of the boat. And I think some of the more sophisticated ones move the petrol around. But their boat does get lighter as the race goes on, which is a bit of an advantage, because the weight of this one stays constant. So as the batteries go down, the voltage will fall towards the end of the race, so the boat will go a bit slower, because it's still pulling exactly the same weight. Another very important thing is to keep the water out of it. Had quite a few problems with seawater getting in. Seawater is incredibly corrosive. When I had some water get in, it completely trashes the bearings in the motor, which is just steel. I've had to change them a couple of times. So now I just do the best I can to keep the water out of us. Making sure the hatch cover is a good seal, and I seal it with it's called hatch sealing tape. It's like big sort of sellotape to stop any water getting in. That's the only place it can get in, is through the hatch, because everywhere else all this is all sealed. Up here we've got a infrared transponder light, which is measured as you go under a gantry. In fact, I'll show you here. There's a gantry. It is anchored somewhere on the course, normally close to where you inland. So, and as you drive under it, the light is infrared is picked up, and it all records your laps and everything, which is really good. So that was the big one, and in the front here you've got a load of this swimming pool noodle stuff for children, and that to cut it up and rammed it all in the space at the front, just in case it gets a hole and prevents it sinking. It will float with hold the boat up. Hopefully it will. And that's about it really. Got a couple of handles for lifting it. It's quite heavy. and I've got a stand here that I carry it around on that I made. That's that one. Now I'll just show you the smaller one briefly. Now the smaller version for 2020, shorter races, same hatch cover, same on-off arrangement here, exactly the same. Two handles, front and back. The whole thing is a bit smaller, and you'll notice straight away the batteries are only half the size. They're 16,000 milliamp hour, 15C, but I'd say they would handle about the same current as those big ones. In series again, both 6S12S giving you 50 volts. Again, there I've mounted on a polycarbonate plate which is screwed to a couple of rails. Same arrangement with the servo here for the steering, fixed on there. Same radio idea here, with all the telemetry and the battery inside. Same telemetry. You can get away with no telemetry if you think you know what you're doing and don't need to keep a check on anything like current draw or temperature or anything else. Motor is a slightly different motor I've used on this one. It's the same size, and it's actually one made by Surpass, or one of their Rocket series. This one says it's a 5th scale motor. They do quite a few different ones, different KVs, and I chose the right one. I'll test it and see if it's the same, nearly the same KV as that one. See if it's better or worse or the same. I've got a little temperature probe on it, check its temperature, water cooling the same. Using the same speed control down here as in the other boat. Same power wires, the fuse, same fuse. So basically everything's the same. The drive shaft are slightly different. I've changed it slightly on this one. Using an exposed drive shaft, running in bearings. This one up here, you can't see it, the drive shaft ran in a tube, but this one is a straight drive shaft all the way through, and it runs with stainless steel. I made that out of a piece of 1/4" stainless steel. Two bearing supports for the, and you can see the propeller. I haven't got the correct propeller on it at the moment. I've got this one's too small, but you can see it drives. It drives at this end. This is where the thrust on the boat is. On full-size boats, that like liners and military boats, etc., they have the thrust block, I think they call it. It's fairly near the back of the boat. If you've ever seen any of the documentaries on TV where they show you the engines, the thrust block is huge, and it's the same idea. It's where it actually pushes the boat. I don't know what if they use bearings or thrust plates or what they use. Most people here use Teflon or something hard, wearing and slippery, that will take the rotational rubbing as well as being able to push. Some people have the thrust on the engine, petrol engine, by clamping it onto the engine so that it pushes here. I don't know, it must make the boat steer or react differently. I don't know, I'm not experienced enough, but mine pushes from the back. And you can pull that shaft out. It's just held on by a small ring here that just stops it. So this is much lighter than the other one. It's not reinforced though. the hull, although this is fiberglass basically, the other one, this one's totally reinforced with carbon fiber, making it very rigid. This one's not quite so rigid, which I'm not sure if that's going to be a disadvantage. The motor can move the hull. I can see it flexing. I'm not sure if that's going to be alright or not. Whereas this, the big one up here, is totally rigid. There's no movement in the hull. I would have done it. I didn't do it. It was too much work to do everything. I hope I won't regret it. So I haven't been on the lake yet because I can't, because everything's shut down. I haven't been on the lake yet. Everything's shut down, so I can't test it. With the same voltage, same motor and everything, a smaller boat, it may be a bit unstable. I hope it won't, but I can always ease off on the throttle. I don't have to go dead flat speed. Again, I can move these batteries a bit backwards and forwards and sideways, and if they're not quite in the right position, I can always make another plate and either move them forward or backwards. But I did do the CFG. It has to be about a third when you pivot it, and I have put it on a little pivot, and it's about the right place, same as the big one. A couple of things: 50 volts. Not for the. You've got to know what you're doing. You can't mess around with these sort of voltages and lipos if you're not very careful with your connections. You don't want to connect this up back to front in any way, or connect it up incorrectly and get some problem. I'm very careful about the way it's all connected up. So, and also if you get a short circuit or anything goes wrong, that's a hell of a lot of current and capacity to be dumped in the boat and could cause serious damage. As I said, I went through a few speedos, mainly because the seawater got on them. These are completely sealed. Motors, I went through a few bearings, again with seawater getting in and rusting out the bearings. But the motors themselves have been very reliable, even though they get pretty hot. I've had some other failures, bits and bobs, connections coming off, things like that. So hopefully the 2020 season, if it ever gets going, and I'll be able to race in more classes and get some more. There's X-Class Sprint, First Class. Maybe they'll be getting some, maybe I'll get some First Classes in the shorter races, and there may be more people entering. I believe there are people interested in do lake racing, and they like to give it a go in the sea. So for those people who do electric car racing, even fifth scale, that's this is quite a powerful kind of a vehicle with the voltage, the motor, and everything else. So roll on the end of this virus, and hopefully the future can get back to normal, and I'll be able to at least race these one more time.